So this is a separable differential equation because the right hand side is the product of something in terms of just x, 3x squared minus e to the x, times something that is a function of just y, 1 over 2y minus 5, right? So let us separate the variables. So first of all, let me rewrite the left hand side as dy dx rather than 1y prime. So now, to separate the variables means that we are moving everything with y to the left hand side and everything with x, which means dx, to the right hand side, right? So rewriting this equation, or separating the variables, we get 2y minus 5 dy. This is the left hand side, equals 3x squared minus e to the x dx. This is the right hand side. So notice that, strictly speaking, it should be a product. Well, then we do integration, right? So in order to solve a separable differential equation, we separate the variables first and then we integrate. Okay, this is a fairly straightforward integral. So the antiderivative of 2y dy is just y squared minus 5y equals 3x squared dx. The antiderivative is x cubed, and e to the x dx is itself, and we shouldn't forget the constant. Okay, the next step is to find the constant. So notice that this is an initial value problem, so which we know because we are given the initial value, not just the differential equation. And if we have an initial value problem, it means that we can find a specific solution, not just all possible solutions. So we need to solve for c. So how do we solve for c? So we use the provided values of x and y, right? So now y is 1, so 1 squared minus 5 times 1 equals, and x is 0, so 0 cubed minus e to the 0 plus c. Now we need to solve for c, right? So this is 1 minus 5 equals 0, so minus 1 plus c. So c equals negative 3. Correct? Yeah, negative 3. Alright, so it means that now we can find c, and then we can just forget about the general solution. So I will replace c with negative 3 here. Alright, and then I will erase this. I don't need it anymore. So now, then we need to solve the initial value problem. So to solve the initial value problem means that we should find an explicit form for the solution. In other words, we should solve for y. Well, whenever possible, but here it is possible. Well, now we need to solve for y. So how do we solve for y? So notice that if we move everything with x to the left-hand side, so by doing this, then we get a quadratic equation, right? So in terms of y, this is a quadratic equation. Now, let us just solve it as a quadratic equation. So the discriminant of this as a quadratic equation, the discriminant is 25, it's minus 5 squared, so 25, minus 4, so minus and minus is plus, applies 4 times this x cubed minus e to the x minus 3. So remember that the unknown is y, so we are solving for y now. So which is why we don't. So currently we pretend that x is a constant. So solving for y, we get y is minus 5 is 5, plus minus square root of the discriminant. So square root of this discriminant 25. But maybe let me continue. Let me simplify the discriminant. So 25 minus 12 is 13, right? So this is 13. Then plus 4x cubed and minus 4 e to the x. Okay. So this is 13 plus 4x cubed minus 4 e to the x. Square root of all this stuff over 2. Okay, so this is the solution of the initial value problem, but notice that we don't know yet whether it is plus or minus, so we've got to pick whether it is plus or minus, right? So what happens if the sign here is minus, if it is 5 minus square root whatever? So how do we check whether it is plus or minus? simple. It's just we use the initial condition again. And so we need to let x equals 0 and see if y is going to be equal to 1. So if x equals 0, if the sign is plus, then we're going to get y equals 5 minus square root of all this stuff is 13. Now x is 0, so x cubed is 0, so minus 4. Correct? Yeah, so e to the 0 is 4. So over 2. 13 minus 4 is 9, square root of 9 is 3, 5 minus 3 is 2, so 2 over 2 is 1. So check, this is the correct value of y. Well, just to make sure that the alternative does not give us a correct answer, so if plus, then if x is 0, then y would be equal to 5 plus square root of 13 minus 4 over 2, and this is 5 plus 3 over 2. 5 plus 3 is 8, over 2 is 4, so this is wrong. Okay, so which means that it's minus rather than plus. So therefore, the answer is going to be 5 minus whatever this is rather than plus. So let me highlight the answer. This is the answer. Good, right? So is it over? Actually, not yet. It is over because, well, let me explain. So what is not done yet? So notice that in the initial differential equation that there is a division by 2y minus 5. But since we are dividing by 2y minus 5, it means that 2y minus 5 is not allowed to be 0. Right? So if 2y minus 5 is 0, then the initial differential equation just, is undefined. So it doesn't make sense. So we need to make sure that we exclude these points where 2y minus 5 is 0 from the solution, right? So the question is, so what if it is 0? So if 2y minus 5 is 0, if the denominator in the original differential equation equals 0, and it means that 2y minus 5 is 0, so y has got to be well, anyway, so let me check, right? So we need to make sure that 2y minus 5 does not equal to 0. So what is 2y? So 2y is 5 minus square root of 13 plus 4x cubed minus 4e to the x. This is 2y minus 5 is not 0. So 5 minus 5 cancels out. So we need to make sure that 13 plus 4x cubed minus 4e to the x, well, is not 0. So moreover, notice that because we are taking the square root and the expression inside the square root should be positive, we should make sure that 13 plus 4x cubed minus 4e to the x should actually be strictly positive. So how do we do that? Well, unfortunately, we cannot really solve this inequality explicitly, but what we can do, we can at least solve it approximately. So we can try to plot the left-hand side of this inequality as a function of x and see where it is positive. So let me do this. Alright, now in order to solve the inequality, 13 plus 4x cubed minus 4e to the x is bigger than 0. So I'm going to just graph the function 13 plus 4x cubed minus 4e to the x, and we see that it is positive on this interval, so from minus 1.445 until 4.63 or something like that. So in any case, you can even graph this in Desmos. So this is the interval on which our the solution of our differential equation is defined, right? So in other words, the answer is that not only the solution of the differential equation is given by this formula, but also it is given by this formula on the interval where x is between minus 1.445 and 4.63, well, approximately, to be honest, but still, this is still a part of the solution, right? So this is a part of the solution.